Hello everyone! In this video I'm going to conclude going over practice test for part 1, which is the paper part that you'll take in class. So I'm going to start with question 13 in this part. So a random sample of 100 American movies from 2022 were categorized by genre and release size. The results are shown in the table below. Perform a chi-squared test for independence to answer the question, is there enough evidence to conclude that genre and release size are not independent? Okay. So chi-squared test is relatively simpler than some of the other tests because there's only one assumption and there's no choices of what you can do. The alternative hypothesis and the null hypothesis are just set for you. All right, so first question is, does the sample data pass the assumption for the chi-squared test for independence? And then if it does not, you skip the rest of the parts. So all you have to check is that it was a random sample, and it does say here random sample. So answer here is yes, it was a random sample. All right. And then for the next part, what is the alternative hypothesis for the test? So the alternative hypothesis is given in the question. Genre and release size are not independent. Okay. And if you check the table up here as well, it's always just that the two qualitative variables are not independent. All right, so maybe I'll just put that right there. Okay, so there's no numbers involved with it or anything, it's just whether or not they're independent. And so the null hypothesis for the test is going to be the opposite of this. So it is that genre and release size are independent. Okay, and then the only part that you have to do any calculations on is making this copy of the table and filling it in the way that you would if the two variables were independent. So there is a formula for this, and it's given in this table up here. So fill each blank entry of the expected table with row total times column total divided by table total. So what we're going to do down here, for example, in this top left entry right here, I would be multiplying 31 times 12, and then I'll divide by 100. Okay, so it's the column total times the row total, and then divide by the table total. So I just got a calculator and did that, and it was 3.72. The next one, comedy drama, wide release, is going to be this 31 right here times 46, divide by 100. And then you just keep doing them all the exact same way and just fill in all 8 of these entries right here. Okay, so I just went ahead and did all of those with the video paused so I don't bore you guys. So these are all the entries that I got. And yep, that's part D. So I guess I'll make those blue. All right, and then the last part here, assuming the p-value is 0.0226, so that's what I got when I did this in Excel, write an interpretation statement for the results of the test. Okay, so the two interpretation statements to pick from, they are exactly the same as for all these other tests. If the p-value is very small, then with a p-value of whatever, there is, pick an adjective evidence to conclude that, and then you put your alternative hypothesis. When p is not very small, with a p-value of whatever it was, we do not have enough evidence to conclude that, and then you put your alternative hypothesis. So in terms of what is very small is at least less than 5%, and some people require it to be even smaller than that. Only you can make up your mind what is very small, but kind of broadly speaking, 5% would be the cutoff for most people. All right, so for the interpretation part right here, this is 2.26%, so I'd say, yeah, it's okay. It's some evidence, I guess, is the adjective I would pick. So with a p-value of 0.0226, there is some evidence to conclude that. And then I'm just going to paste my alternative hypothesis. Genre and release size are not independent. Okay, so that is it. And let's go ahead and look at the next one. So a random sample of 100 American colleges were categorized by type, public or private, and region, Eastern or Western. And this is real data again, I didn't make it up or anything. The results are shown in the table below. Perform a chi-squared test for independence to answer the question, is there enough evidence to conclude that college type and region are not independent? Okay, so first we will check the assumption. We just need to check if this was a random sample, and it says that it was. So I'm just going to type that at the end of the line here. Yes, it was a random sample. All right, alternative hypothesis for the test. So just looking at the question here, the alternative hypothesis is college type and region are not independent. So I'm going to paste that down here. All right, and now for the null hypothesis, I'm going to take the alternative hypothesis and just make it the opposite. So college type and region are independent. And now for the table entries, again, for each cell, I'm going to multiply the column total times the row total, and then divide by the table total. All right. Okay, so here are the entries that I got. And now the last question in this part. Assuming the p-value is 0.5890, write an interpretation statement for the result of the test. So this is nowhere near 5%. This is 59% approximately. So we're not going to be able to make a conclusion. So with a p-value of 0.5890, we do not have enough evidence to conclude that, and then I'll put my alternative hypothesis, and that is it. All right, so the last question of this type. A random sample of 100 American colleges were categorized by type, public or private, and selectiveness, high, medium, or low, based on admissions rate. The results are shown in the table below. Perform a chi-squared test for independence to answer the question, is there enough evidence to conclude that college type and selectiveness are not independent? Okay, so the assumption for the test, again, is just randomness, and it does say random sample right there. So yes, it was a random sample. Okay, and now what is the alternative hypothesis for the test? So again, I'm just grabbing this from the question. College type and selectiveness are not independent. All right, and then for the null hypothesis, I'm going to make it the exact opposite, that they are independent. And now to fill in the table entries, again, for each cell, so for example, this one, I do the row total times the column total, divide by a table total. Okay, so these are the numbers that I got. And now the last question is, assuming the p-value is 0.0180, write an interpretation statement for the result of the test. Okay, so this is about 1.8%, so I'd say it's decent evidence. So with a p-value of 0.0180, there is, I guess, enough evidence to conclude that. And then what I wanted to conclude was college type and selectiveness are not independent. All right, so public versus private. Well, let's see, which one was it actually? So highly selective, the privates, yeah. Yeah, public has a higher number in the low selectiveness, and private has a higher number in high selectiveness. So yeah, private are a little more selective than public. All right. So the last two questions here are about linear regression. So obviously you can't make the chart yourself, but you can look at the equation and you can use the equation to make a prediction with just a calculator. So number 16, a linear regression analysis was done of all movies released in American theaters in 2022, using the number of theaters the movie opened in and the maximum number of theaters the movie played in. So there's a really strong correlation, as you guys can see. 0.9481 R-squared value is about as high as you'll ever find in any real-world data set. So I think what's going on is that a lot of movies never went to more theaters than what they opened in, so the two numbers are the same, which means they lie right along this diagonal line here. And then in some cases, well, nobody went below it, right? Because you can't have your max theaters be less than what you opened in. So that explains a lot of what's going on in this graph. Anyway, I digress. So the results are shown in the picture at right. Use the regression equation to predict the maximum number of theaters for a movie that opened in 1,000 theaters. Okay, so the number that it opened in, that is your X value on the horizontal, and the number of the max theaters, that is your Y value. So what we're going to do is plug in X. We're going to plug in for X with 1,000, okay, and then we're going to see what Y is. All right, so we're using this equation that is on the Excel chart right here, 0.9744x plus 11132, and then we are going to plug in 1000 for x, and then we're going to add 11132. Okay, so you can grab a calculator and do that, and you get 1085.72. So at least it's not, if you got something less than 1,000, then you know you did something wrong. But there's a little bit more than 1,000, and it looks like most theaters never, most movies never open in more than, or sorry, they never play in more than what they opened in. So 1,085 kind of makes sense roughly. All right, so that is that one. And then for the very last one, a linear regression analysis was done of all movies released in American theaters in 2022 using the domestic box office and the international box office. The results are shown in the picture at right. Well, it was right when I was on the print view, now it's left, sorry. Use the regression equation to predict the international box office for a movie with a 200 million domestic box office. Okay, so we're just doing the same technique here. Domestic is the X value, horizontal. So we're going to plug in 200 million for X, and then Y is the international box office. So we're going to see what Y comes out to be. All right, so we are using this equation that's on the chart, 1.3979x plus 22782. All right, and then for X, we are plugging in 200 million. So I have to make sure I get the right number of zeros. All right, and then I'm going to plug that in a calculator carefully. Okay, so here's what I got, and let me put some commas in here. So comma, 279,807,802, and I guess that's dollars. All right, so that is the end of the practice test part 1. So this is the practice for the paper test that will be given out in class. And in another video, I will go over the Excel problems. Send me an email or come to office hours if you have any questions.